also relevant when you do series. So let's go through logarithms. Okay. All right. Okay. So, logarithm. What are logarithms? We first need to know what are index form. So this is called index form. So the index form is, this is the index. This is the base. Right? So when you write it in log form, we make the index the subject. So you write x equal, the index the subject, x equal to log a, and that y, actually log of y, so it's been changed, so x is on the left, y is on the right, log y, and the base is a, right? That a there. Okay, so this is called the log form. So index form to log form. And we're going to do more practice with these. So let's practice these. Let's do the first one. Now, what's 2 cube equal to? 2 cube is 8. And we're going to write that in log form, right? 3 equal to log base to 8. Okay? So that's what log means. So it comes from index. Now, what's 3 square? 3 square is 9. So you write 2 equal to log of 9 base 3. Okay? Right, good. Next one, 5 to the power negative 2 is 1 over 25. So we get the index, the subject, which is log base 5, 1 over 25. Yep. And finally, 16 to the power half is 4. It's a square root, so you write half equal to log base 16 4. Okay. Log. Okay, good. Any question? Now we're going to go back to the other way. You should be able to write log form into index form. So what you need to do is just go 2 to the power of 4 equals to 16. That. And the next one, 5 to the power of 3 is 125. And then 3 to the power negative 1 equal to 1/3. And the last one, 49 to the power of half equal to 7. Okay? All right, now once we do this, we're now going to do more questions. So now we know how to convert. Now we have to work out what log of 81 is. Okay? Now remember, log of a number is the index of a number. So the question is, what index 3 has to raise to get the answer 81? So you have to ask yourself, 3 to the power of what becomes 81? What would that power be? 4. Okay, so we can check that with a calculator. 3 to the power of 4, 81. So the answer is 4. Okay, because 3 to the power of 4 equal to 81. That 4 is the answer. Okay, try another one. Next one's a little bit harder. The number got smaller. So think about what power you have to raise 36 to get the 6. You got smaller, so what will it be? A half, yeah, because if you go square root of 36 is 6, right? So square root of 36, which is 36 to the power of half, and that equal to 6. So the answer is half. Okay? Alright, how about the next one? 10 to the power what is 0.01? 10 to the power what? 10 to the power of a negative power. 0.01, negative 2, so write negative 2. because 10 to the power negative 2 is 0.01. Okay? Alright, next one. How about the next one? So if you have a 2 here, it means 2 times. So you have to work out what log 1000 is. Log 1000. What's log 1000? 3, because 10 to the power 3 is 1000. So you get 6. Okay? Yeah. Alright, good. Now we can actually, there's actually a log button on your calculator. You've used it before. We're going to talk about it again. So there's a log button on your calculator, which is over here. So there's the log button. Okay? So we're going to use that button to calculate log. Okay, so there's a log button, so it's right L-O-G, log button. So that log button means the base is 10. Okay? So that button has a base 10. But they don't write it, but it's a base 10. So if I want to do the first one, log 17, base 10, you write log 17. And then close bracket equal to 1.23. So write about 1.23. Yep, 1.23. But what does the 1.23 mean in this context? Yep. All right. Okay. 1.23. Now, what does it mean? It means that if I raise 10 to the power 1.23, I will get the answer 17, or at least close to 17. So that's what that 1.23 means. Let's check it on the calculator. So if I go 10 to the power of 1.23, I will get close to 17. Okay? So that's what that log gives you. It gives you an index. That's an index. Okay? So I want you to do three these questions on your calculator. Write them down. So write down log of 7, 0.85, and do the other two, 0.85, and then do log 1 as well. Log 1, 0, and then do log 0.7, 0.7, which is equal to negative 0.15, negative 0.15. Okay? Alright, so what do you notice about these numbers? You get a positive, you get 0, you get negative, right? And when is it positive, as long as you substitute a number that's more than 1, it's going to be positive. If you substitute exactly 1, you get 0. And if you substitute a number less than 1, you get negative. So it has some strange properties. Okay? And this is true in general, not just for base 10, works for any base A. So you can write it's positive if x is bigger than 1. It's equal to 0 if x is equal to 1. It's going to be negative if x is less than 1. Okay? Alright, so this fact is important, so I suggest you to highlight this because that's quite, I think, important. Okay? Alright, let's go back to the next question. Next page, we're going to use a calculator. There's another button on your calculator called ln. That ln stands for log base e. We learned about e already. So log base e is ln 5. And there's a button there which you can see, ln. That button there. So it's ln. So I want you to use this button to calculate this. The answers are given. So give you about 3 minutes to calculate this. Okay, so that's calculator skill. So for example, if I do the first one, I do ln 17, you should get this answer, okay? And then for the next one, you do ln fraction ln 5 close bracket over 3. You get this answer. Okay, just the calculator skills. And notice that these two are different, okay? So be careful. All right. So try this now. Give you about a couple of minutes, and we'll continue. All right. So anything 1 must be 0 because 10 to the power 0 is 1. So if you struggle to do that, because 5 to the power 0 is 1, so the answer is 0. So you don't need a calculator for that. And when they're the same, the power must be 1. 10 to the power 1 is 10, so the answer is 1. And not just for 10, it works for 40. 40 to the power 1 is 40. So the answer is 1. Yeah? Okay. So you don't need a calculator for that. So we know that in general, log of 1 is 0. And log AA is 1 if they're the same. Okay? So you have to memorize. This you have to memorize. So let's use a highlighter, memorize. Okay? Not on the formula sheet, so you have to remember. All right, there's some restriction on log. Log can't take a negative number nor 0. Why is it like that? For example, why can't I do this? So 10, so log base 10, negative 2. Let's try with the calculator. What if you do log negative 2? It will give you an error. Now, why do you get an error? Because 10 to the power what becomes negative. There's no number that works. Because if you draw that graph, it can never be negative, right? So no solution. And the same thing, log 0 is the same. 10 to the power what is 0? Again, cannot be 0. So no solution. So for this reason, if I find the domain of log x is actually x bigger than 0. It can only take positive numbers. Okay? Write it down. Right, after you finish, you're going to look at the graph of log, then we're done. Then tomorrow we'll do some log law. On Thursday we'll do log laws. Okay, next one, graph of log functions. So to examine log function, let's start with the exponential function because they're related. Fill in this table of values, 1, 2, 4, 0.5, and 0.25. Okay? Okay. All right, let's plot the points. So we got 1, 2, 3, 4. 1, 2, 3, 4. So let's plot the point. The first one's 1, and then 1 is 2, 2 is 4. Okay? And then go halfway, and then it gets closer and closer to the x-axis. So you get these points. So this is your y equal to 2x, an exponential function with a horizontal asymptote at y equal to 0. Okay, draw that. So it's pretty easy. Okay, after you do this, we're going to try to do the log graph. For the log graph, you're going to put 0.25 there, and then 0.5, 1, 2, 4. So just copy this down into the x. And then what you do is, if you try to do log base 2, what's the answer? Log base 2, 1, right? How about log base 4? What 2 to the power what is 4? 2 to the power of 2. And 2 to the power what is 1 is 0. Yes? And that will be half. That will be negative 1. That should be negative 2. Okay? So what you do is, if you plot the points, you will get these points. 1, 2 is 1, and 4 is 2. And then you get progressively closer. So you get this graph. Okay, this is your log base 2x, the log graph. And the log graph will have what we call a vertical asymptote. Vertical asymptote. Vertical. Okay. Alright, so what do you notice? You will notice that, in fact, they are a reflection of each other, isn't it? They're reflection. Reflection, you will learn about more of this in the inverse function topic, inflection, about y equal to x. Okay? Alright, good. Alright, any question? Now, in addition to that, we need to know the graph of exponential and log ex. We just did exponential last lesson. Let's go through this again, so you can use your calculator to do this. To shift this, shift that. No, shift this 1.5, so it gives you the decimal 4.5. Do this in like this. And the other one, that's 2.7. That will be 1. And the last one will be -1. That will be 0.4. And then plot the points. So you get 0, 1, 1, 2, 3, 4, and 1 is 2.7, and then 2 is 4.5. Three, 4.5. There. And then 0.4. So you look the same graph, isn't it? Y equal to e to the power x. And then we can do the same thing with log ex, because all you have to do is just use the ln button on your calculator. ln3, 1.1. Right? ln3. And the other one, ln2. ln2, 0.69, or just 0.7. ln1 will be 0. ln.5 will be 0.5, will be -0.7. All right. So let's draw the graph. So we've got 1 here, 2 is 0.7, 3 is 1.1, and then you get -0.7. Alright, so you get something like this. And same thing with the asymptote as well. With the asymptote here. Okay? And write down the equation y equal to log base ex. Okay? Right, any question? And to summarize, we can write down the domain and range of log. Domain is, domain for a log graph will be x positive. Okay? But the range is actually all real x, all real y for log. And the asymptote is x equal to 0. Y equal to 0 is the horizontal asymptote. That's for the exponential. So the exponential have a horizontal asymptote. The log graph have a vertical asymptote. Yeah. All right, it's been solved. Okay, good. Now we're going to sketch this. Hopefully remember what that does to the graph. What does x plus 2 do to the graph? It shifts to the left. Very good. 2 units. So let's draw that. So we have a log graph that looks like this. Right, that's the log graph. It shifts to the left 2 units. So it's going to go over here. So which is going left 2 units will be -1. And the asymptote will be now be -2. -2. And then it's going to go like this. Right, shift to the left 2 units. And you can also find out the y-intercept, isn't it? How do you find the y-intercept? You do x equal to 0. And if you put x to 0, you get y equal to ln2. So it's ln2 here. Okay? Alright, graph is drawn. Alright, how about if it's not inside the bracket, it's just plus 2. What does it do? It shifts up 2 units. Okay, so let's draw the original graph here. That's the log graph. Y ln x like this. Oh, so we're going to add 2. So this one will be tricky because it doesn't have a y-intercept, so we can't use it to help us. So if you go up 2 units, it's just going to go up 2 like this. So this point here, there, like this. So the gap between them is 2. You'll still have the same asymptote, but just the gap will just remains at 2. Okay. All right, good, like that. Won't be able to work out what the x-intercept is because we haven't learned how to solve. There will be a different x-intercept. So this is y equal to ln x plus 2. Okay, so this is just log and ln, so you can do the exercise today, exercise 4.4. Okay, so you can start the work now. All right.